Hi, I'm Doug Black at Inside HPC. Thank you for joining us today at Virtual ISC. Today, we're talking with three HPC analysts about this year's conference, some of the more important developments, announcements, and trend lines that emerged at ISC this year. With us are Steve Conway. He's a Senior Advisor, HPC Market Dynamics at Hyperion Research. We have Addison Snell. He's co-founder and CEO of Intersect 360 Research. And Shahin Khan, he's a partner at the consulting firm Orion XNet. Gentlemen, welcome.
Thank you.
Thanks, Doug.
So Addison, let's start with you. This year's ISC was digital once again due to COVID-19, but beyond conferences, what effects has the pandemic had on the HPC market?
I think it's had an effect on everything, of course, and the HPC market was no exception. We saw a lot of disruption worldwide, economically, of course, socially, and all the health tragedies, as Thomas Sterling was just pointing out in his final keynote of ISC. HPC, though, kind of goes both ways. First of all, there was obviously a negative effect on a lot of spending in many markets where we saw a lot of, in our surveys, people reporting their budgets getting canceled or more often delayed or put off a purchase. But then we also saw a lot of areas where HPC was involved in the fight against COVID-19. National lab spending was up. Biosciences spending was up. A lot of projects were going the other way, getting created or accelerated. So it was really a lot of variability where some sectors were down, but a lot of HPC got deployed in the battle against COVID-19. One really notable thing that I'm pretty sure we'll come back to at some point in this panel is cloud, which was up substantially because cloud has a lot of flexibility. It does well with uncertainty, and cloud computing was certainly involved in a lot of the COVID-19 response.
Yeah, we'll revisit cloud a little bit later. Now, Steve, I know you're interested in issues around national and regional indigenous technology. What are the impacts that initiatives in this area have had on the global HPC community?
The impact has been moderate so far, but it's bound to become larger. It's sort of a good news thing that governments around the world have recognized in recent years, sort of finally, that HPC is good not just for science, but for economic and industrial competitiveness. That's one of the reasons why these big sums are being given for exascale development. So that's the good news for HPC. There's a difficult, possibly kind of a transition period here where you see, as you see in Europe in particular, some struggle between the interests of researchers and those wanting to build up the domestic supply chain. But in the end, this is going to be a good thing. There'll be more choice because there'll be more products from more places in the world. It won't just be the US and Japan, as it's largely been historically kind of colonizing HPC systems around the world.
Okay, great. Now, Shahin, let's turn to you. I think you have some thoughts on the latest benchmark tests that we've seen recently, HPL, the Green 500. What are your thoughts in that area?
Yeah, definitely. Something that's been interesting to me is that we started out, obviously top 500 is always anticipated, even when it doesn't change a whole lot. It's indicative of a whole lot of different things. And the team there does such a great job of encapsulating all the implications of it. But something that we are seeing is that we started with HPL, initially LIMPAC 100, and then LIMPAC 1000, and then HPL, and then Green 500, HPCG, IO 500, and now HPL AI. And within Orion X, we actually do our Crypto Super 500 that Steve Perrineau does. Fabulous work that you should go check out on our website. And we just announced another installment of it today. So this all kind of points to something, and it points to the diversity of applications that HPC systems must run. And I think that points to heterogeneity that we're going to talk about as well. So that's all really very interesting to me, and how the metrics of HPC are evolving with the new sources of data and the new applications.
Okay, great. Now, Addison, back to you. There was a lot of talk there. There's constant talk about AI and HPC. How is AI changing the HPC landscape?
Yeah, in the near term, it's really brought a lot more attention to high performance computing in general. They're the two things that can largely go hand in hand. And what we found is that the majority of the time where we've got overlapping HPC and AI, or rather in HPC, among HPC users, 80% already have machine learning or AI implemented, or they're actively working to implement it within the next year. And that's generally with overlapping infrastructure, overlapping teams, overlapping budgets, not exclusively, but that's the predominant way we see it. And where that is happening, there is an increase in HPC spending. Now, there's certainly some pockets of non-HPC users that have never used high performance computing for anything before. Maybe you're a hotel chain, you don't do HPC, but you're trying to look at, can I use AI to predict occupancy rates or something like that? There, rather than moving on premises, almost all of that has gone into the cloud. So we're seeing an uptake of high performance computing technologies in that sense, but not on premise. So in the near term, there's been a lot of things that are really consolidated. What we don't know is how much that'll stay the same versus different in the longer range forecast. We already see a lot of people who look at data science and AI as a different sort of workload for HPC that in the long run is requiring different configurations. And you could see these start to migrate apart. It's a different infrastructure, different team, different budget. So in the near term, they're accelerating each other. We're seeing more HPC and more AI together, and AI will certainly influence how we do HPC with configurations, with precision of arithmetic, and there will be some long range implications for even traditional high performance computing. In the longer run, though, some of the data science machine learning applications could start splitting off into being really a distinct market.
Yeah, lately I've been seeing increasingly the term AI supercomputing as a distinct kind of a thought.
Yeah, that's a funny one. I used to know how much a gigaflop was, right? And now we don't know how much a flop is, because not all flops are created equal. That's really mostly referring to reduced precision, mixed precision. For traditional high performance computing, I still prefer to look at the traditional double precision calculations, just so we can have consistent measurement going forward, rather than invent new units and try to compare against them. But that's a personal preference. It's not that AI mixed precision isn't valuable for those workloads. Of course it is.
Yeah. Now, Steve, your thoughts, you have some thoughts about the prospects for ARM and RISC-V as x86 alternatives.
In our kind of latest study of user sites worldwide, what we're finding is some consistency. We're asking them, as we always do, what's going to be the main base processor CPU for your next major system? And 82% say x86. That compares 4 years ago with 84%. So it's really not a change. What's different is what makes up all the rest of the other preferences. And 4 years ago, zero, not one site said ARM was going to be the main CPU. Now it's 5%, not a giant number, but something interesting. And 28% said that there are going to be some ARM processors in their next major HPC system. So something's happening there. And it looks like, ARM is the next thing as kind of a rising processor. RISC-V is starting a little bit later, but it is coming along after.
Well, ARM on top of the top 500 list, and then the NVIDIA acquisition. I spoke with some NVIDIA people yesterday, and surprisingly, they wouldn't tell me anything. They would give me no update on the acquisition.
I just saw that it got go ahead in Europe. So anyway,
it did. Okay.
There's also interesting ARM activity in Europe. With the European Processor Initiative and some other things happening, and in the UK too, with Isambard and all that, and of course in China, there are interesting ARM developments too. So it's not just limited to what we see on the surface.
Yeah. Now, Shahin, coming out of ISC, what's some of your latest thinking in the areas of openness, heterogeneities we're just discussing, and integration?
Yeah, I think one of the interesting things, as Steve was mentioning, ARM, of course, is ascendant, and they had a great day when on the same day, Fugaku got announced at the very top, and Apple announced going to ARM at the very bottom. And that scalability was so patently visible. That was, I mean, and good for them because they do a fabulous job. But then you have RISC-V coming right on their heels with full openness. And I think openness, the way RISC-V is doing it, is very significant, because the problem with kind of licensable IP versus not licensable IP is really clear cut. But licensable IP without friction is a really big deal. And what we are observing is that open source is as successful as it is because it eliminates friction. And even a tiny bit of friction, those who do marketing like I do as part of what we do, know that the moment you just add another click on your website, you reduce the number of clicks by like 90%. That a little bit of friction can have a giant impact. So RISC-V is cracking the code in having frictionless IP and architecture that goes forward. I'm not too kind of bothered by ISA itself. I don't think the ISA itself is really that material. I think fab is a lot more important than ISA. But the openness is a really big deal, and the building of the community is a really big deal. And we're now seeing it kind of rise all over the world, from China to India to Europe. They moved their headquarters to Europe. All of that is really very important with RISC-V.
I like to talk about risk. Sorry, I didn't mean to interrupt, Shahin, but I love the point about ARM and risk. Steve, you're talking about the mix of the everything else that's changing. The question is what's going away, and it's been IBM Power, which is kind of a shame because you still got Summit and Sierra up there in the upper echelon on the list, and IBM has sort of stopped focusing on HPC, and we're seeing where ARM has really replaced that role that Power used to have in people's mindset of a processor that's not x86. I'm sorry I interrupted, Shahin. I just like the points that you and Steve were making. Steve, you were on mute there. Sorry.
No, I think that's a great point, Addison. And it's interesting. People want an alternative processor, just to have an alternative in the bidding, for one thing. But what's interesting is that neither x86 nor the NVIDIA GPU were originally designed for HPC.
No, that's right.
They've both been very successful in their way, but there hasn't really been a tight fit, glove fit kind of a processor for HPC. And I'm not sure. I guess the big question mark is HPC a big enough market to have its own processor?
The thing that
ARM, is as big as it's gotten. It's not as big as the hyperscale kinds of things and how much they order in the way of processors.
I think AI is what
you mentioned the Apple. TSMC has kind of cleared the decks for the Apple processor. So I mean that sort of tells you something. So it's going to be interesting to see how much momentum and how customizable these processors will be for HPC.
That's right. Now, IBM was on the right track with OpenPOWER, and I wish they had been more visibly successful with it. But they kind of clearly got it. And of course, they were one of the advocates of Linux, so they definitely get openness in a big way. But it did not translate to power fast enough, apparently, right? So we are where we are now, where you really talk about x86 as the bloodstream of computing continues to be, and thanks to AMD, the flag continues to be waved prominently. But then you also have ARM, you have to have RISC-V, and that may be enough, at least for servers. When you go to microcontrollers, a whole bunch of different dynamics show up. And that stuff is also important, because I think as great as cloud is and as fast as it is growing, 2021 may also be the year when it is going to have to share the stage with the edge and with all the other infrastructure that is out there. That there was, for a brief period, we thought that you could have your iPhone at one end and cloud at the other end and you were done. Well, that picture never happened. Now you have a lot of infrastructure everywhere in between. Why? Because there's just too much data. And when you have too much data, you have to decide whether you want to keep it, you want to process it, or you want to ship it. And you have to do it at every step of the way. And it is more advantageous to actually have infrastructure everywhere rather than ship everything to the cloud willy-nilly. Now, cloud does have kind of a black hole nature. So the moment data goes there, it keeps accumulating. So you kind of have that, and then you get this new data gives you new applications. That leads to heterogeneity. That leads to the whole Cambrian explosion of AI accelerator chips. You see, I did mention Carl with Cambrian mentioned. So now you kind of have
the pricing of power was an issue. I mean,
right, for sure. Yes, and that's volume.
Like
yes.
The guy who owns the clothing store and every suit is priced at $1 million, but he only has to sell one. It's not that exaggerated, but the price was tough.
That's true. That's true. But then we had a talk, like we mentioned in the other chat, about is storage memory blaring? Now you're kind of putting logic inside memory, both physically and semantically. You're looking at in-memory, at-memory, non-von Neumann architecture. So what is interesting to me is the combination of heterogeneity on the one hand, but then high integration from another hand. And then openness that really leads to heterogeneity because it allows all these multiple things. That combination is really interesting to me, open heterogeneity integration.
Okay, so let's move over to cloud. I know, Addison, you have some thoughts about new cloud systems in the top 30 of the top 500. What are your thoughts about what cloud and HPC will look like by the end of the decade?
Yeah, I love that we're talking about how the top of the top 500 list does have influence over the rest of the market. And just wrapping up that architecture comment, Shahin, you were making the point about that influence at the top. Notice that the x86 exascale plans are only in the US, and there's only one exascale computer plan that's based on Intel x86 right now. And outside the US, they're not x86 at all. So you wonder if that means a different direction. But with regard to cloud, we are seeing these Microsoft systems for Microsoft Azure that are up there. What's noteworthy about that to me is that they are intentional HPC configurations that are configured for HPC users, for HPC workloads with InfiniBand. There have always been hyperscaler cloud service provider like systems that are up there. A lot of the volume of the Chinese systems that are on the top 500 list are in fact not HPC systems at all, but they're hyperscale infrastructure that they've run LinPack on and replicated. This is very different. This is HPC infrastructure that really is for HPC configurations, and I think goes along with this trend I was mentioning where we're seeing a very high double-digit growth rate on cloud. And last year in 2020, in direct response to the pandemic, it was nearly 80%. Now, that's not to say it's going to be 80% every year. That had everything to do with the COVID effect of cloud picking up the slack, both coming and going. If I delay a purchase, I can use cloud in order to pick up the extra cycles while I'm waiting for new systems. If I'm accelerating projects, I can use cloud before I get things through the procurement process. So cloud picks it up on both ends, and we expected to see a big bump in cloud last year, and we did. It's not going to continue at 80%, but having it continue in the 20s compound annual growth rate over the next 5 years is totally feasible, and that's largely replacing a lot of the growth that we would have otherwise seen in entry-level HPC systems. That growth rate is flattened out now, and even the mid-range, we've seen a blunting of the growth rate there. It's all got to go somewhere. It's not like budgets have suddenly exploded by that much, but seeing these intentional HPC systems on the top 500 list from Microsoft, I think is indicative of where a lot of this spending is now going.
Yeah, cloud HPC seems to be finally happening.
Intentional is a really.
I was going to just say that you kind of think of that UK Met procurement. That's an interesting one. Microsoft kind of with Cray behind the scenes, or HPE Cray, is kind of interesting. But I think it's the juxtaposition of HPC, cloud computing, and edge computing is going to be very, very interesting in the next decade, because HPC has an important role to play in that kind of a configuration for kind of deeper situational awareness. Things that don't need high latency. Low latency at the edge. HPC is going to have a very, very important role to play there, and already is having.
But
Yeah, that's
from
that triangle I drew while Shahin was talking, that edge to core to cloud. It's going to be data movement and data sovereignty are really what's going to drive that.
You are so right. And to me, one of the questions I'd sort of be interested in your opinion, Shahin and Addison, on this one is, this sort of race between the cloud and the on-premises stuff. It looks, well, what our surveys are saying, and I'm guessing Addison, yours do too, is that the ultimate barrier at the moment is data locality. And you already see the CSPs allowing people to buy kind of pieces of the rock, pieces of their infrastructure that are installable on premise, whether or not they're hooked up to a regional cloud. And so you kind of see the CSPs and the on-premises folks kind of battling it out for market share in HPC, and data locality is what people, it's surpassed data security as the main issue for determining what goes to the cloud.
Oh, I believe it, because the most expensive thing in computing is moving data just when all the applications are going big data. So that obviously forces you to think twice about where you place and where you move the data from. It's also true that something like 80% of the data is being generated outside of the cloud, out in the edge, and ultimately consumed there too. So it really makes no sense to ship data there only to bring it back, especially if you're going to pay a lot for it. So that is, I think, one reason why we are going to see this edge to core to cloud as a new model that is kind of replacing the mobile cloud, simplicity that we enjoyed for a while.
Yeah, data locality and data sovereignty are the key issues in deciding which workloads you can move to cloud. In terms of how many you move to cloud, if you're an established HPC user, the number one barrier is cost. Because let's stop pretending you're going to save any money by doing that if you have an established HPC center. That's never been true. It's not going to be true in the very near term. So cost is really the number one consideration. But then once you've decided, I'm going to break something off and move it, it's the data locality and data sovereignty issues.
What is clear is that cloud is not a replacement for on-prem. Right. And what is clear is that cloud is not going to go away. So basically, the complexity of coexistence and integration of the whole thing is what many people have to look at.
Well, and it's interesting, our periodic surveys, we finally got smart enough to ask the question we should have asked all along and didn't, which is, how easy is it for you as a data center manager to know where to run a particular workload in a cloud, on premises, hybrid, whatever? And the answer in most cases was pretty easy. So there's not a whole lot of market education. There's some, but there's not a whole lot of market education that apparently is needed out there. They know what they're doing, but it's like what Addison says, cost.
On whose authority? In the specific, when you go say, all right, I'm going to move this job to cloud, well, whose decision is that? Does the individual engineer or scientist have carte blanche to just put stuff to cloud whenever they want? Or do you need someone who's a PI or a project lead or a technical lead, someone with budget authority who's going to give you that approval? And that gets really different in the specific instances by organization.
It is, and it's interesting you should say that, because we were at one of the big three auto companies, and hearing the HPC data center manager talk to us about this and that, what was going on. And then we said, can we talk to some of the engineers, the design engineers? And they had a different story at that time. They said they were all using OpenPOWER in the cloud.
Right.
And we said, well, it's not as accurate as, the ISV application you're using. They said, it doesn't matter. Because we used to, in the 2 months or 6 weeks we were given in the cycle, we used to be able to try out 4 or 5 designs. Now we can try out 10,000 with today's HPC systems. So each try doesn't have to be exactly as accurate. And this way we avoid the queue. Since that time, the data center managers have kind of wised up to this, and they say, hey, we're going to, if you can't beat them, join them. They're now managing all of that, including out to the cloud.
All right, great stuff, guys. So Steve, I know you have some thinking about what it will take to advance to the next significant steps in AI.
Well, AI is as we all know, is very, very useful with today's methodologies, but it's in a very early stage. And some of the things that, as everybody on this call knows, that need to be tackled are explainability, because you can't trust what's happening out of multi-layered neural networks. That kind of is an issue, particularly when it comes to things like healthcare decisions and whether you're driving a semi-automated car, what's it going to do, or why did it do it, that kind of thing. So that data volumes in a lot of these domains that are important, where HPC is involved, like precision medicine and so forth, there's not nearly enough usable data. So there are a lot of people working on synthetic data. That's going to be very, very helpful. More has to be done on the inferencing side. So much attention has been on the training side, but the IQ of the works is kind of more on the inferencing side than the training side. And the inferencing side doesn't have the opacity type issues, the black box issues as much as the training. But the biggest one is the base methodologies. There've always been two approaches to AI, and the dominant one today is based on learning models, which are essentially path problems. That's what they can tackle. But there's forever been the alternative, which is looking at kind of deeper layers of what happens in our brains, more symbolic representations and so forth. And the people who say, yeah, we got to get that involved, they argue that this could be 80 to 90% of human intelligence that's being ignored by learning models, because these are innate things that aren't learned in the first place. So learning models don't help. And there are people working on, combining these methodologies, fusing them again. And that really is the most fundamental thing that needs to happen. We don't know quite how far deep learning as a methodology is going to take us, but it's doing very useful things right now.
It is the only thing that's really working and has moved the needle.
That's right.
And of course, the commensurate data volume issue, because it turns out you need a lot more pictures of cats than you thought you did to recognize them. So now that means that you have to manage the data. So what I'm seeing is that decentralized ingest, decentralized cataloging, decentralized access, finding the needle in the haystack, all the problems that were hot for a while and then went away are all coming back. And how do you curate that data? You look at the POSI square kilometer array. Ugo gave a beautiful talk this morning, and just the sheer magnitude of what they're talking about. So what comes across to me is that you've got continuous streaming, nonstop data, and you've got continuous learning, and it's decentralized. You combine those three, and it's absolutely an HPC class problem. It's an exascale data problem.
Well, HPC is pretty indispensable at the forefront of AI R&D, which means that anybody wanting to know where AI is going, it's not a bad idea to look at what's happening with HPC today.
Absolutely.
Yeah. So Shahin, my last question for you is going to be about data management. Do you have any other thoughts you'd like to share, or have we kind of covered that?
I think we have, and of course we could talk about this all day, and we kind of are.
All right. Well, I want to thank all three of you. That was a great discussion. Really appreciate your insights, and great to be with you today.